Hi Calc, this is answers to the quiz that you took today, if you're watching today. Let me go through an explanation. So, number 1, it will not factor in the bottom. So there's nothing to really factor, but you can plug in a -1 on top and plug in a -1 on the bottom. Just make sure when you're plugging in negatives that you use parentheses. So when I simplify the top, I get 0. When I simplify the bottom, I get 2. So 0 divided by 2 is 0 for an answer. Number 2, this part of the limit is when I said before, like memorize this or keep track of it. So we have a -2 on top, and this limit is just equal to 0. So -2 times 0 is also 0. Perfect. The third one involves multiplying by common denominators. So I see an x plus 2 and a 2. I'm going to multiply every single term by x plus 2 times 2 on the numerator. So I'm multiplying by everything and distributing it. So in the first fraction, the x plus 2's cancel, and I just get a 2 on top. Then I have a minus sign, and I'm going to put parentheses because the 2's cancel, but not the x plus 2. So there's 2 terms left, and parentheses are important. And on the bottom, just rewrite it. You have everything left. No need to multiply it out. Now when I plug a 0 in, whoops, not yet. So I'm going to distribute the negative sign, and on top I have just a -x left, and on the bottom I have a 2x and an x plus 2. Now you see you can cancel out the x on top and the x on the bottom, so that no longer is a problem of 0. So I have a 1, a -1 on top as a placeholder, and then a 2 and an x plus 2. And now when you take and plug in 0 for x, you're going to have -1/4 for an answer. All right, problem 4, you can factor out an x on the top, and that leaves you with x plus 2. And then notice you have an x plus 2 in the denominator. So if you try to plug in -2 originally, you will have a 0 in the denominator. So that is a bad thing. So now I can easily plug in a -2, and I will get just -2 for my limit. So there is a value at x equals -2 that makes the original graph discontinuous. And since I got rid of the problem, that is called removable. All right, first, is this function continuous? Sure, all quadratics are continuous. There's no problem with any number, like making a 0 in the denominator, nothing at all. And let's find out the value of -2. Plug in -2. And don't forget, again, use parentheses. 3. And then we'll also plug in a 1 and do that same calculation to find out if -3 is between. So this top one has a value of 5 and the bottom has a value of -4. So yes, -3 is between those two values. Finally, here's what to do to solve the last one. Right here I gave you a hint. Let's add 3 to both sides so you can get a 0. And I added 3, so I got +0. And now let's factor and set each one of these equal to 0. So x is either 0 or x is positive 2. Now I want to go back and look at my original interval, and only the 0 is the one value that's in the interval. So if I plug a 0 into my original function, you get a value of -3, and that value is in between. So it does work for the IVT. Problem 6, here are two parts of this function. It's called a partial function, and the left side is the top one. Notice a little left of 0, x is less than 0 would be a little left. So if I plug in a 0 into the top number, I get 0 squared plus 1 for part A, so that value is 1. Part B, notice there's a plus sign. That means a little bit bigger than 0. So that is the bottom function. So plug a 0 in for x there, and you get -3. So on the left it's 1, and on the right it's going to -3. Because they don't match, you cannot find one single limit. You have to have matching on the left and the right. So at 0, it does not exist. For problem 7, notice it is -1 from the right side. As I am approaching -1 from the right side, it looks like it is about like 0.8. I don't care if you wrote 1, that's fine. Part 8 says -1 from the left side. So here's my function coming in to -1 on the left, and it looks like it is headed right towards the number 3. Okay, why is this graph discontinuous at x equals -2? Well, first of all, the function's value at 2 does not equal the limit, at -2, does not equal the limit as the function is approaching -2. See, the function's value is 3, but the limit is 1. So those two items have to be totally equal for a graph to be continuous. That's where it fails. All right, thanks for the extra effort today, and hope you are enjoying the good weather. Bye-bye.